An infinite network. As shown in figure, a network of resistors of resistances R1 and R2 extends to infinity toward the right. Prove that the total resistance of the infinite network is equal to R1 plus square root R1 square plus R1 R2. Since the network is infinite, the resistance of the network to the right of points C and D is equal to RT. Okay, so this is the hint we will use. So that means we have A, B here, C and D at these points, and then we have exactly the same thing giving us the resistance we are after, that is RT. Okay, now you can see that RT is in parallel connection with R2, so that the equivalent resistance of RT and R2 is R2 RT divided by R2 plus RT, two resistors connected in parallel. Now R1 is in series connection with another R1 and RT2. So this has been replaced with RT2. R1, R1, RT2, they're connected in series so that the equivalent resistance, which is what we call R total, is actually 2R1 plus R2 R total divided by R2 plus R total. So we can write this as 2R1 R2 plus 2R1 RT, R2 plus R2 RT for the common denominator, R2 plus RT. So let's do that. We have R2 RT plus 2R1 R2 plus 2R1 RT, that is equal to RT times R2 plus RT, which is R2 RT plus RT square. So here we have RT square plus R2 RTs will cancel out. RT square, so if I take 2R1 R2 to the right hand side, I will have minus 2R1 R2, and then I will have minus 2R1 RT is equal to 0. Or this can be written as RT square minus 2R1 RT minus 2R1 R2 is equal to 0. And this is a quadratic equation. The solutions are of the form minus 2R1. So it is 2R1 plus or minus square root of the b square minus 4ac, which is 4R1 square plus 8R1 R2 divided by 2. So this gives me R2 is equal to R1 plus or minus R1 square plus 2R1 R2 inside the square root, but the minus 1 is not physical because it would imply negative resistance. So the correct answer is RT is equal to R1 plus R1 square plus 2R1 R2 inside the square root. Okay, so once again we have an infinite network. So this whole thing after CD, R1, R2, R1, 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 R2, etc. This thing is infinite. Therefore, the answer for this question between A and B is equivalent to the answer for this question between C and D. So this part is what I'm after. So that is in parallel with R2, in series with R1 and R1. So I can use that to calculate RT, because the answer for the equivalent combination here is RT. So I have R2 RT over R2 plus RT replacing this part in series with 2R1. So this gives me the equivalent resistance, which is RT. Solving for RT, we obtain a quadratic equation, and the equation, we only take the positive solution because the negative resistance doesn't make any sense. It's not physical. So this is the proper solution, and that's what we were supposed to obtain. RT is equal to R1 plus square root of R1 square plus 2R1 R2. So this is the correct answer. So there is a 2 missing here, apparently. So this is square root of R1 square plus 2R1